Hey everybody, Bill Sky, the COBOL guy, and today we're going to talk about calling functions from other languages, specifically C and C++. So with that said, I'm going to split these videos up, I don't know, 2 or 3 different videos. This one's going to be on simple calls to C and C++, and then we're going to have another one on sending arrays to C and C++, and we might even do one as to how to call a Fortran function from COBOL. Now, one thing to remember when you're calling functions from other languages, there's a conversion that has to take place, or a compatibility that has to take place. And that compatibility are data types. For instance, what is a comp1 variable in COBOL? How does that equate to a C or a C++ data type? Or for that matter, a real in Fortran, how does that convert to C or C++? Or how does that convert to COBOL? So you have to worry about that, and that's the very first thing you need to do if you're at work or you're at school and you're given a project to do this conversion or to call these functions. The first thing you need to do is go to the programmer's guide and find that information out. So I think what we should do before we do any coding is we take a look at that. Okay, so I'm going to go ahead and open up my COBOL template here. And within that template, I've actually added the programmer's guide for GNU COBOL, and that's what we're going to do today. We're going to use GNU COBOL. Now you have to worry about this for whatever language, if it's Microsoft COBOL, if it's Micro Focus COBOL, or GNU COBOL, or mainframe COBOL. You have to do this. You have to take a look at what the conversion or what the compatibility is. So I'm going to create my new project here, and I'm just going to call this calling C, because that's what we're going to do today. And when I go into there, I thought I had that that user's guide in there, but I don't. So what I'm going to do is I'm going to go to my host location. Actually, let's not do that. Let's go on the internet and let's go find that. Let's go find that. So I'm going to say GNU COBOL Programmer's Guide. Okay, I believe that's it right there. Okay, well this is the online one. I'd like to actually, let's go to manuals and guides. Let's see if we can find documentation and support. Okay, here we go. So here's the PDF for the GNU COBOL 3.2 Programmer's Guide. And I'm actually going to download, it looks like I did download it. So let's go to where I downloaded it. There it is, GNU COBOL. I'm not sure why they called it letter, but okay. Let's rename that. And let's open it up. Now I actually have the page in my notes over here. And I believe it's page 706. And I just did a search on it. Well, it looks like I might have used an old one, so let's do this. Let's do a search for C++. So I kind of found it in a kind of, I went down to index and I went looking for C. And there it is right here. C main programs calling GNU subprograms. So I went ahead and clicked on that. That's page 84. And then I scrolled up and I saw it right here. GNU COBOL main programs calling C programs. Subprograms. And then when I went up a little bit further, you can see this conversion. So here's a binary char unsigned. That's the same as an unsigned. So this is the COBOL data type, and this is the C data type. And you can also see down here that we've got comp1 and comp2. Comp1 is a float, comp2 or computational 2 is a double. And for a long double on C or C++, there is no thing on GNU COBOL equivalent. Now again, it depends upon your compiler, so you need to go ahead and take a look at your compiler, your particular compiler's programmer's guide. And as you can see, it can be a little bit of a challenge to find that, but some guides are better or worse than others. So anyway, so that's the first thing you want to do, is you want to take a look at that. So once you have that, and I'm going to keep this up here because we're going to need it. I'm going to go ahead and keep that up there, and then I'm going to go ahead and start editing our program. So I'm going to open up my COBOL program, and we're going to use Genie, and that way we can do the Makefile. And I'm just going to go down here, and you can do this on any operating system, no problem. I'm going to go ahead and make clean, and then make, and then run it, and so our COBOL compiler is working. Hello world. All right, so let's go ahead. I'm going to call this program test C, and I'm going to change the date to today. And it's called test C, so we have to come down here to the bottom. Let's change it here. All right, we're all set. And actually, I'm on Ubuntu 24 now. Actually, I'm on Alma Linux. I'm on Alma 9.5. Let's just say Alma 9. All right. So these are all things that you do when you get started. All right, we're still looking good. All right. So the first thing that I want to do is I want to create a C function. So I'm going to go ahead and create a new file, and in that new file I'm going to go ahead and just create a very basic function. So within that file I'm just going to say #include stdio.h, and I'm just going to say void hello world. And I'm just going to say printf hello world, and then close off the function. Now the reason why Genie is not parsing the language is because I haven't saved this file yet. So let's go ahead and save it. And unfortunately it doesn't take me to where we are, so we have to navigate there. Okay. And I'm going to call this cfuncs.c. cfuncs.c. And now you can see Genie is now parsing it. Now, I can't really call that function yet. Well, I can. I can go up here into the main COBOL program down in the procedure division, and I can go ahead and call that, but it's not going to link correctly because we haven't compiled it yet. And actually, let's change this hello world from C, so we can see the difference between the hello world from the main COBOL program and then the hello world from the C functions. All right, so the next thing we have to do is we have to open up our Makefile. Now right now the Makefile's got a lot of stuff in it that we don't need. We can keep it there, but that's okay. So what I'm going to do is I'm going to make some changes. I'm going to create a new section that's going to take main.o and cfuncs.o, and what it's going to do is it's just going to do the link. Right now the main is doing the link and the compile, but because we're going to be having to do two compile steps, we're going to have to compile the cfuncs.c using the GCC compiler, and then the main.cob or CBL, whatever it is that's .cob, we're going to do that with the COBOL. So let's go ahead and do that. So we're going to create a main.o and cfuncs.o, and under main, or the old main, I'm going to make that main.o. It depends upon main.cob, and it's just going to do a GC And let's go ahead and take out this. Okay, that looks good. Now, we also have to add the cfuncs. So let's go ahead and add that. .o. That's going to depend upon cfuncs.c. And that is going to do a gcc-g-c cfuncs.c. Now, the other thing we don't want to do is that we don't want to delete the .c. We want to delete the main.c. Now, the reason we don't want to delete all .c's is that we're creating a new .c file. So we want to put in the clean. We want to make sure we delete only the .c that is created by the COBOL, the GNU COBOL compiler. All right. So I'm not sure if this is going to work, but let's go ahead and make it. Okay, what happened here? It looks like it compiled it. Okay, that happened on our COBC. So let's take a look at our Makefile. We don't really have that just right yet. So let's take a look at our main.o. I believe that's where it happened. Debug. Oh, I think we need... Oh yeah, let's get rid of this dash free. Let's get rid of that. I think that was the problem. And then let's make it again. And we still have a problem. So let's say make clean. And then let's say make. All right, let's take another look at this. We're not doing the free, so let's move that free down. Okay. And COBC, let's say COBC dash dash debug dash G dash C dash X main dot. I'm not really sure if that, okay, let's take a look. So cfuncs.o relocate, oh, so something wrong with cfuncs.o. So let's take a look at our link, because it looks like it did the compile of the COBOL program okay. It looks like it did the compile of the C program okay, but it died on the link. So let's make sure that our link up here is working. This is dash x dash o main.o funcs. Let's make sure that our cfuncs.o is correct. C-X-O main.o. Well, let's see. It might be the compiler. I originally did this on a Debian Linux. This is a Red Hat Linux. So it says down here, recompile with dash FPIE. So let's try that. So we're going to do... in this, because it's saying cfuncs dash FPIE. Let's see if that fixes the problem. It looks like it did. Okay, great. So yeah, I paid a little bit more attention to the linker messages, and it looks like that our compiler is a little bit different on this version of Linux. All right. So now let's go ahead and let's call our hello world from C. Now we're not sending it any variables yet. We're going to do that next. So let's go ahead and just call it. So from our our compile program or COBOL program, let's call the function. Now one thing you want to make sure when you're using your editor, and I haven't used Alma Linux on this, on these compiles. So I want to make sure my indentation is spaces. We don't want tab characters. So okay, so I'm going to say call. Let's make sure we got the function name right. Call hello world. And we're not going to do any using. Using is what you would say when I want to send it variables. All right, so let's go ahead and make it, run it, and wow, there we go. Hello world from C. Now we really need to put something in there, so let's put a \n, make it again, and run it. And there we go, hello world from C. All right, so we've called our first C function. I think the next thing we should do is that we should send some variables to that C function. So what I'm going to do is, actually we have to create a function first, but let's take a look at our COBOL program. And down here in the, get rid of some of these comments. Okay, so down here in the working storage section, what I'm going to do is I'm going to create some variables. I'm going to call one hello. And I'm going to create another one called world. I know, very basic, but that's okay. All right. So we just created a couple of variables. That's all we did. And we're going to send those variables to another function. So let's go ahead and make it. All right, we've got an issue here. Let's see what the issue is. Oh, I forgot my X. And the X doesn't go in there. It goes pick X. Didn't have my coffee this morning, but that's okay. All right, great. So we've got our variables. Now, how are we going to call this function? So let's take a look at our procedure division. And I'm going to say display using our say function. I'm going to call it say. I'm going to call the function say. I'm going to say call say using hello and world. So what is this function doing? What is this call doing? It's calling the say function, and it's going to use two variables. It's going to use the hello variable, and it's going to use the world variable. And here's the hello variable, and here's the world variable. Let's go ahead and save and run and build this. And this is what's kind of interesting, is that when you compile the program and then you link it, it doesn't actually resolve the external functions until runtime. So the compile and the link worked. Now if you compiled it statically or you linked it statically, then that might fix this issue. And we're not really worried about that right now. What we're just worried about is interlanguage communication. So as you can see, we got an error that it couldn't find say in our C program, even though it compiled. So let's go ahead and create that function in our C functions file. All right, great. So let's say is going to return an integer, and we're going to send a char pointer and another char pointer for hello, the hello variable, and the world variable. And I'm just going to create a little function. And this is kind of interesting because these are char arrays. These are C strings. So a little bit of code here. So you can see how we're going to be processing two arrays. All right. And then let's close off this function. Now let's go back to our main and let's change this right here. Let's call this Hello World 2. Let's make these 8 characters. And then let's go back to our C and change this from 7 to 8. I know this is real backward, but I'm making a point here. All right, let's go ahead and make it, run it, and it's testing. Yep, there it is right there. So hello 2, world 2, and then the program ends. Now, what we might want to do is I might want to say put char. To give us a new line. Let's go ahead and make it again. And now it's looking better. Now, this is pretty cool. You can do this, but the problem is that this particular char array, it must always be 8 characters in length. It must always be an 8 characters in length, and I don't think that's a good way of doing it. So what I'm going to do is I'm going to say create another function called say2, and this function is going to take 4 arguments. It's going to take an integer and size 2. So it's going to take 2 integers. Size 1 will be the size of the hello array. Size 2 will be the size of the world char array. And now instead of saying 8, I'm just going to say size 1. And down here I'm going to say size 2. So now we have our say2. So let's go back into COBOL and let's call our say2. And let's go ahead and put a little display in there. Say2 function. And we'll say say2 hello size 1 size 2. Now we haven't defined those variables yet, so let's go ahead and do that. So I'm going to say 1. So let's create a 1 data variable, and we're going to call this we're going to call this hello world 05 string 1. That's going to be a pick x20. And let's just say value spaces for now. And we're going to do another one too. Now let's go ahead and put our integers. So we're going to say 0, 5, string 1, size. That's going to be a pick. Let's see what size we want to make that. I want to make sure I make it the correct size. Okay, so let's make that a pick 9.4. I'm going to say usage is binary and value 20. All right, so let's talk about this a little bit. Why did I say pick 9.4 and why did I say usage is binary? Because this is basically what a C, C++ integer looks like. And let's go over here, and usage is binary. Okay, binary int is the same as a long int. I could have said binary short, which is an int in C, but I would have to specify in the C program long int if I wanted to make it binary int. And I believe binary by default is a binary short. So if I just say binary, it's the same as assigned short. So that's why you need this programmer's guide up, is so you can make sure that you're doing things correctly. So I could say binary short if I want. Let's do that. And let's go ahead and create our string 2 size. All right. And we made those 20 because each size of our strings are 20 in size. All right. So let's go ahead and make this. Oh, so we still have an issue. So it's string 1 size and string 2 size. So let's say string 1 size and string 2 size. Now let's make this a little bit better. Let's go ahead and put our string 1 in hello world, string size in hello world, and you'll see why I'm doing that is this in just a moment. String 2 in hello world and string 2 size in hello world. So a little bit different of syntax than we've done before. What we're doing here is by saying in hello world, I can have a string 1 subcategory of data within hello world, but I can also have string 1 in some other subcategory. Like let's say if I wanted to create 2 of these, hello world 2 as the O1 level, string 1 can exist in both. The variable name can exist in both, because what we're going to be doing is we're going to be saying in. We're going to be saying I want string 1 in hello world or hello 2. So let's go ahead and make this. And I believe we've got a little bit of an issue. What's it say here? Let's clear this out. Let's go to the top. Okay, it says string 1 size cannot have a picture clause. Let's take a look at line 24. It might be because of binary short. Let's go ahead and take those out and see if all of our problems go away. Little idiosyncrasies in the language. But all languages have that. And now it's built, okay. Woo, weird, right? So not sure why that was, but I could actually leave this pic94 completely out. I believe it'll work. Nope, in this case it doesn't work. So we need to leave that in there. In this case. All right, let's go ahead and make it. Run it, and well, we got an issue. Well, we've got garbage. First of all, we haven't put anything in these string 1s and string 2s, and we've called say 2. So let's go ahead and say move string 1 in hello world. Got to be careful. There we go. Move. All right. Let's see what we've got now. Okay. Testing our say2 function. We sent it, but it didn't print anything out. So what I'm going to do is I'm interested to see if it actually got through that. So I'm going to say here, display program ending. Let's see if it actually got it to the end. Okay, program ending and have a nice day. So we know the problem is in here. So C2 for I equals 0, size 1, size 2. Oh, okay. One thing about sending data to a function like this in COBOL is that you might want to specify how are you going to send it. Are you sending it by reference? Are you sending it by value? What I'm going to do here is I'm going to say using by reference string 1. So I'm sending a pointer by value length, or the string 1 size, by reference, because I believe it sends it default by reference in GNU COBOL. Let's see if that's the case. And that's definitely the case. So because we sent it by, we did not say by value for the string size, our function in C would have to change to be a reference variable or a pointer variable. So this way we're specifying that we want to send it by value. We want the actual value of our string 1 size to be sent and not a pointer to it. So very good error. This showed us that we specify. Now we don't have to specify by reference here. So I believe if we get those out of there, oops, it'll still work because by default it is sent by reference. And what did we do wrong here? Because we used it once down here, it's kind of like, well, you should be using that for all of them. So I'm going to add the reference back. So once you say by reference or by value on one variable, the GNU COBOL compiler kind of would like you to use both. So there you go. So that is our say2. Okay, let's create another function where we add a couple of numbers. We do some actual arithmetic and then we return that data. So what I'm going to do is I'm going to create a couple of variables up here in working storage. Okay. And I'm just going to copy this one. And I'm going to call this O1 numbers to add. And we're not going to have any X values, so let's get rid of those. And I'm going to create a variable called number 3. That is going to be a pic 94. Usage is binary. Value 0. And let's just go ahead and leave the 20s there, but let's make all these variables similar in name. All right. Let's make this. Oh, put a semicolon. That's one of the dangers of working between two languages, is that you begin to mess up. All right, good. All right, now let's go ahead and call that function. Now we actually haven't written the function yet, but let's go ahead and call it, just so you can see. Testing add to function. This is mainly for debugging. You can get rid of those displays. And I'm going to say move 100 to number 1 in numbers to add. Move 200 to number 2 in numbers to add. And be careful on Genie when you press the period. It's going to go ahead and, would you like to select a number from within that group? I just press escape. And then I'm going to say call add. I'm not sure why I called it add to here, but okay, let's leave it that way. Add to using by value number 1 in numbers to add. Oh, don't want to put a period there. And then I'm going to say by value number 2, put a space there, in numbers to add. And it's going to be returning a value, so I'm going to say returning number 3 in numbers to add. And then let's go ahead and display that value. Now we've gone past the 80 character, so let's go ahead and just put that there like that. Okay, so this function add to is going to take 2 arguments, both integers, number 1 and number 2, and it's going to return number 3. So let's go ahead and create that function. Int add to. It's going to take an integer num1, integer num2, int x, x equals num1 plus num2, return x, very, very simple function. All right, let's make it. And let's see what it says. Unknown statement. Oh, I typed in display wrong. Dispally. All right, let's build it. And let's see if it worked. Okay, so I moved, oh, I keep forgetting to put that \n. So it looks like it worked because I've moved 100 into number 1, 200 into number 2, called the function, and printed off number 3, which is the return value. So let's go ahead and clean that up a little bit. Oh, yep, it has to happen inside of... Nope, not a \n, just needs some spaces there. And looks good. All right, now there's another way that you can get the return value of an integer, and that's a thing called return-code. It's a reserved word in GNU COBOL. Don't remember if it's in mainframe or other COBOL programming languages, but it is there. I could just simply say display return from add2 using return code is, and just say return-code. So you don't actually have to say returning. You can just specify return code because that's the variable that's actually going to have it. Now it may be it's showing 0 because we did something up here. So let's now call add2 again, except this time let's get rid of the returning. Now it is possible that because we said returning, it didn't put the data into return code. I haven't tested that yet. But let's see how that works. And you can see 300 there. And return code also has a different format to print out, to display. All right, so that was that one. Now let's go ahead and let's do some floating point stuff. Floating point is something that we always want to use. So let's go ahead and say what is our function going to look like when we call it. So what I'm going to do is I'm going to say call, and let's just say multiply 2. We want to multiply 2 floating point numbers. Using by value, I'm going to create some variables, float1, in numbers to multiply by value, float2. Again, we haven't created these yet. In numbers to multiply. And then I'm going to say by reference, return float in numbers to multiply. Now, there's something funny going on with GNU COBOL in that if you call a function that's going to return a double, that's going to return a floating point, I haven't been able to get that to work like I did with integers by saying returning. So what I'm going to do here is I'm going to call the function and send 3 arguments, 2 by value, which are the 2 numbers that I'm going to multiply together, and then a 3rd argument, in this case return float, which is going to be sent by reference, which means that the C function can then update it because you're updating the real thing. You're not updating a value or a copy of it. So that's kind of what you have to do with GNU COBOL. So I'm going to say display result of mul2 is return float in numbers to multiply. Yeah, so every COBOL implementation has a little bit different of an implementation or a capability. So you have to learn that in the programmer's guide. All right, so let's go ahead and now put in our data definitions. Let's do some different data types. Just to show you their compatibility. So what am I doing here? Float long is exactly the same as comp2. And again, if we come down here to the programmer's guide, comp2, the developers of GNU COBOL didn't really put everything in here, maybe because it's just too much. But computational 2 is exactly the same as float long. So comp2 is the same as float long. Computational 1 would probably be the same as float. So that's just trying it out in experience, trying to make that work. So I just put those in there to show you that they are going to be the same. And let's see if everything looks good here. Okay, everything looks good. So let's do a make. And we're going to get an error because we try to call a function that doesn't exist. And let's put a little display in here for testing. All right. Now let's go into the C code and let's go ahead and implement our mul2. Now we're going to make this really a simple function, but it's pretty important how you set it up. Okay, so void mul2 double num1 double num2, but remember we sent it by reference from the COBOL program, so we're going to say double asterisk return val. Not a double asterisk, but it's a double, it's a floating point pointer. So we're just going to say dereference return val equals num1 times num2. Very simple function. All right, let's make it. All right, we got some code problems here. Let's see. Return val, not return value. All right, let's run it. Oh, okay, the result is 0 because we didn't put any data into there. All right, into those. So let's say move 99.97 to float 1 in numbers to multiply. Move, let's say 18%. Let's say we're doing a tip here. And let's put an E there and a 0. All right, let's make this. And you can see that we got our calculation, or 18% calculation of that. So that's sending floating point. Now again, on this mul2, if I did something like this, if I did the returning, let's see what happens. It isn't right. There's some problem or there's some implementation that I don't understand in GNU COBOL as to why floating points cannot be returned correctly. It also might be something in the programmer's guide about that. And we could take a quick look. I'm not sure. I've never looked into this. So let's say returning a float. They don't have anything in the programmer's guide. So I'm not really sure what the problem is. And I feel kind of guilty asking them because they're doing this GNU COBOL for free. So there's always workarounds in a language, and in this particular case, this workaround is necessary. The returning just will not work when it comes to floating point. So we just go ahead and send a variable by reference, and then that's it. Okay, let's do one other function. I'd like to create a function that takes a string that I send it, and I'd like to have that function modify it directly. So what I'm going to do is I'm going to say I'm going to create a function called dash out. And what that function is going to do, it is going to take a string and it's going to actually modify that string from within the C function. Now, to do that, I'm going to say by reference, I don't know, a variable called string, and then we're going to say by value and int, because I need to tell the function just how big the string is or how many characters to process. And I'm going to say display value of silly string after dash out is, and let's say silly string. Okay, so this will be a little bit additional array kind of stuff, which we're going to do numeric arrays in a forthcoming video. All right, so let's create silly string. And let's just do those as 77 types. We don't have to put them in a structure. All right. All right, there we go. Now we have to put data into those before we call the function. So let's say move and then let's just change the first 5 characters. So move 5 to and in. And now let's go ahead and define that function. And I believe it was called dash out, yes. So let's go ahead and define that function in our C. And the first one will be a char pointer. And the second one will be an integer. Okay, so one thing I want to do in this function, I'm going to say if string length is less than equal to 0, I'm going to return. I'm doing a little bit of argument validation here. Else, oops, let's close that. Else, I'm going to say for int I equals 0, I less than string length, I plus plus, string of I equals dash, and then close off the else, and then we'll close out our dash out function. And I think it might be a good idea to put this display before and after, and say before dash out. Okay. And let's see what we did wrong here. It says we have 5. We have a problem here. Oh, I have a double quote there for some reason. And it looks like we have a problem in our... Oh, yep. So I said string. I should have said string 1. Dash out not found. Up because I have a capital. And there, it worked. So great. But what if you would like to just dash out an entire string and you don't want to have to worry about how long it is? And you can do that in C very easily by looking for the null character, because all C strings in C and C++ are terminated with a null character. In GNU COBOL, it's the same way. And I don't know if that's the case for all COBOL compilers and operating systems. I don't remember because it's been a few years since I've done mainframe development. And I don't remember ever calling a C or C++ function from within a COBOL program when I was doing mainframe work, because everything was in COBOL or it was in assembler language. So, but in this case, let's go ahead and let's create a function called dash out 2. And instead of having string length, just have the string. We don't have to worry about this. And instead of a for loop, I'm going to say while string 1 of I is not equal to \0. Now we do need a counter, and we do need to increment the counter. So this way you don't have to specify that you want to, you don't have to specify the length of the string that you're processing. And let's go over here and let's call dash out again. Except instead of dash out, we're going to say dash out 2, and we don't need this second argument, so we just get rid of it. And let's see. And we have a problem. Oh, int plus plus, I'm sorry. Yeah, this doesn't exist in C++, so we have to say, oh, no, it does. We have to say I++. I said data type int plus plus. Okay, what did we miss here? 54. Oh, put a semicolon there. Get rid of that semicolon. And it worked just great. So you can see right here, before we did the dash out, hello there, y'all. Then we did the dash out with 5, just the first 5. It did that. And then we used the same silly string variable, except this time we just used the \0. We used dash out 2, and you can see right there that it went and it processed the entire thing. One last thing I want to talk about is C++. Everything we've been doing here is C, but what about C++? Well, let's go ahead and create, I'm going to select all of the code here. And I'm going to create a new file, paste that code in there, and I'm going to say file save as cfuncs.cpp. Now this will not compile correctly, or it may compile correctly, but it won't run correctly. And the reason for that is because C++ has a different calling structure than C does. So what we need to do before all of our functions are defined is I have to say extern C, and then I can indent all of this, and then down here I can close that off. So what this means is that every one of our functions is now a C function. It is now should use the C calling standards. So I'm going to get rid of my cfuncs.c. I'm going to save this. I'm going to go into my Makefile, and instead of cfuncs.c, I'm going to do cfuncs.cpp. Instead of gcc, I'm going to say g++ pp. And this should build. Let's see if it does. Okay, so let's see. I've got a problem here. cfuncs.o, cfuncccpp, cfuncccpp. Oh my! Yeah, I don't have the. Where's my cfuncs.cpp file? I didn't save it correctly. So let's say save as. Let's make sure I save it in the directory where my project is. All right, now let's see if it makes. Let's run it. Wow. So I took all of my C functions, put them in a new file called cfuncs.cpp. I added the extern C. If you don't do that, the C++ compiler is going to compile it differently than the C compiler, and it's not going to work correctly. I can demonstrate it, but you can try it yourself. So in case all of those functions in an extern C, change your Makefile to use the G++ compiler, dependent upon CPP and cfuncccpp. Make sure you save that file. Jeannie didn't save it in our current working directory, so I had to save it again. I think it probably, I'm not sure where it saved it. Oh yeah, it saved it in my home folder. So let's get rid of that. Okay, so yeah, it was a little bit confusing there. So there you go. So now we've taken all those C functions, we put them in a C++ file. Now I haven't been able to get the GNU COBOL C++ interface working because I don't think it's meant to work that way. C++ is so different. So you definitely want to put all of your functions into a C library. And if you want to use C++, you can do some kind of a wrapper function around it to call the C++. So basically what I mean by that is that if you do have a C++ function, hello, of whatever it is, you can create a C function, put that in the extern that calls that C++ function. So that way the calling interface works. So you could do some, so let's say you have a function up here called, let's say int sum array. And this is a C function, or C++ function. And you want to be able to call that from your COBOL. Well, the only way to do that is in the extern C, you have to say int call sum array. And then you can say you can say return some array of Now, I'm not really sure if this will work, but let's take a look if it builds. Oh, we didn't do a return. Actually, we did do a we didn't do a return up here. So it compiled okay. We haven't really used it, so we're not really sure. But we might do that in the upcoming video on array processing when you call a C or C++ function from COBOL. So that's one way to get around that, is by creating the C wrapper, the C function wrapper that then calls the C++ function. All right, long video, lots to take a look at there. Go ahead and rewatch the video. Go between the chapter links, figure out. I really recommend that you start from the beginning because each part of this video builds on the previous part. And our next video is going to be on array processing in COBOL with C++, calling a C++ function. Hope to see you there.